First of all, I'd like to thank the organizer of Pycon PH for giving me the opportunity to speak today. I'm delighted to be here. This is my first time in Manila. It's been great so far. I arrived this morning actually after having slept for only 3 hours in the plane, but feeling great. Great to be here. Excited to give the talk. And thank you so much for coming over, and I hope you learned something new today. Just a little bit about myself. I come from Indonesia. I grew up in Jakarta, but at the moment I'm living in Bangkok. That's Sawadee Khap. Is there any Thai here? Any Thais? No Thais. Any Indonesians? One Indonesian, okay. Where are you guys from? Philippines. Mostly Philippines. Okay, great. Great to be here, guys. Actually, a little bit about myself. My background is actually in economics. I studied economics in Cambridge for 4 years, but then I decided to focus more on statistics, and I moved to Oxford to do a master's degree in statistics. That's where I got acquainted to software engineering. And after that, I started becoming an algorithmic trader, and that's where I really honed my skills in Python and software engineering. A couple of years ago, I decided to move back closer to home, to Bangkok, where Agoda is headquartered. Sort of. I mean, Agoda is actually legally in Singapore, but then the biggest office is in Bangkok. I always say tongue-in-cheek that I was the A/B testing police there. And Agoda is one of those companies that is really obsessive about running A/B testing. They do like thousands a quarter, and they need someone to look after the A/B test. So, as was stated before, I co-founded Arithmox, which is, I guess, in simple terms, it's a tech consultancy that focuses on optimization for the manufacturing industry. So we go to traditional businesses and try to guide them in their digital transformation. But enough about that. I want to talk about property-based testing. Who here has heard about property-based testing? So not so much. Who here writes unit tests? So a lot of you, okay, good. Who here likes functional programming? Oh yeah, that's someone who's 2 hands up right there. So you like this, you'd like this. And property-based testing, I mean, if you do already write unit tests, you should be able to just start writing properties with a bit of help. And I really hope this talk will try to inspire you to do that. So firstly, I want to go through the what and the why, right? What is property-based testing? Then I want to introduce Hypothesis, which is the go-to library in Python for you to do property-based testing. And we'll just see some code there, and we'll see how easy it is to write property-based tests. And common patterns are very important, because if you're used to writing unit tests, it might be a bit unnatural for you to start writing properties, but with just some templates, just getting a very high level overview of what kind of properties you should be writing, you'll be there in no time. And just to inspire you a little bit, we'll look into bigger examples and case studies where property-based testing has been useful. Please do stop me anytime if you have any question. I'd rather make it interactive rather than me having to babble on and then people getting lost. So please stop me anytime. Okay, does that sound like a plan? Yeah, thank you. So what is property-based testing? I think one quote that really captures the essence of property-based testing is that normal automated testing is surprisingly manual. And what David McKeever, which is the author of Hypothesis, the library that we're going to be looking at next, is that what he means is that whenever you do unit testing, you always have to come up with some data. The data is fixed. It could be that you're making it up. It could be that the data is there, right? Like you've recorded it somewhere and then you need to retrieve it. Or you need to mock it. But there's always this initial cost for you to come up with some data. Then you perform some action to it, and then you assert something about the result. that's a unit test, right? And the only thing that's different in property-based testing, at least at the very high level, is that instead of making up or coming up with these data, you try to generate them. So you write a generator for your data, and then you try to assert something about the data for all possible inputs. And obviously, you cannot assert the result, because if it works for every possible data that you generate, then you might as well have written 2 different implementations of it. So you'll assert something different about the data. It'll be clear once we see some examples. But let me just hammer in on why, right? Why do we want to generate and not write? And I think this is very important to get right. The first thing is writing tests is not scalable. It's not fun. Like, okay, maybe you have a really nice TDD cycle, you have a nice example, and just to be secure, you write your second example, maybe your third, your fourth. But after that, like, it starts getting really boring. Like, it's laborious, it's not scalable. So you want something that works for every possible input. So even if you have like 7 test cases, it's still probably very small, like just 7 points out of all the possible inputs that could possibly enter your program. And secondly, it's actually very hard to write good example cases. And I mean this in the sense that everybody has blind spots whenever they're writing code. And by definition, the blind spots means that you're not quite aware that some of the edge cases of your code, right, of your input. So it's very difficult for you to put that in the unit test to begin with, because it's your blind spot. But what if you have a data generator that just generates all possible inputs and then hits all these edge cases? And it'll be very nice for you to just verify some properties. And thirdly, a failing example does not tell us why it fails. We'll see a case study later on about this, where we have a very complex system and there's a sequence of actions for you to replicate a bug, but then you don't know why. Yeah, you just don't know why. And if you don't know why something fails, then it's very hard to debug. So you want something to find a minimal failing example. And just a bit of history. The first property-based testing tool is actually implemented as a Haskell library. Who here knows Haskell? Yeah, a few of you, but it's a really nice functional programming language. It was QuickCheck was written in 1999 by Khong and John Hughes. It's still very actively developed, and if you go to Haskell, you start writing some Haskell code, you're bound to meet some QuickCheck code. And in particular, John Hughes, this man, he founded a company called QuickCheck, which is a QA company, and it uses a lot of QuickCheck to do testing for stateful systems. So we know that these kind of techniques is being used in the industry. It's just not just an academic exercise. Okay, so I've sort of like danced around, right? Like I haven't really defined what a property-based test is. Part of the reason is because it's quite difficult to define what a property-based test is, because different implementations have claimed it to be different things. But if we just look at all the different implementations of a property-based test library, I think we'll find 3 things that's very common. And without one of these points, that no longer becomes a property-based testing framework. The first thing is that you need a property, something that holds true for all valid data. So this is your assertion. So this is what makes it a test, right? And secondly, you need what's called a fuzzer, or your data generator. And the emphasis here is on generating a large number of inputs. So you don't want to generate 7 or 8 data points. You want to generate something that you wouldn't write by hand, like hundreds, thousands. So you need to test a large number of inputs. And finally, it's very important as well, this notion of a shrinker. So once you find a failing example, you want to be able to shrink it, to make it as simple as possible. So there's this notion of size, of how complex the data is. Find a failing example, you try to shrink it to make it as simple as possible that still fails, so that it's easy for you to debug. Again, we'll see an example on this. Some people say property-based testing is the thing that QuickCheck does. That's not the case, right? There's some incidental features of QuickCheck. And today we're going to focus on hypothesis, which is the go-to library in Python. This is David McKeever, who's the author for Hypothesis. Let's just get straight into it, right? As promised, there will be code. I hope that's visible even from the back. Is that visible from the back? Okay, awesome. I've got a thumbs up. I've got 2 thumbs up. So, what does a property-based test look like, right? It looks very similar to a unit test. Here I'm testing whether or not the addition operator is commutative. So it's something very trivial. So you always have your assert, you assert something, but then what's different here is that you've got this decorator. The given decorator makes it a property-based test, so that here I define 2 arguments, x and y, and the given decorator matches the argument list. So that now I'm saying, given 2 integers, this thing always holds true. And in hypothesis, for whatever the fuzzer or the data generator is called strategies. So here we have strategies for integers. So this is an example of property-based test. Very simple. How do we run it? Just like how we run a unit test. I use PyTest, but you can use any other test, like you can use unit tests if you like. And this is easy, right? But this is not so helpful because what happened here? Is it really running a property-based test? We can actually look under the hood, and then we can have this this command line argument, hypothesis shows statistics, where it basically says, hey, I ran 100 examples, all of them passed, and I'm happy. Yeah? What about failing tests? What does it look like? So here I'm trying to do something stupid again. I'm going to test whether or not subtraction is commutative. Obviously it's not. And if I run this, it says, hey, I found a false example. Test subtraction is commutative. It's not true for x equals to 0 and y equals to 1. And that's simple enough. And I said that, well, I mean, these strategies generate random integers, and then it tries to do the assert. It's actually not a coincidence that it came up with 0 and 1. This is again the idea of shrinking, the idea of you wanting to find simple data, so that it's helping you to debug this. And you can see this by looking at the show statistics. It actually it's saying, okay, I ran 2 passing examples, but I found 11 failing examples. But it didn't report to you straight away. Try to shrunk it. And once it's shrunk it, it tells you, hey, 0 and 1, this is the minimal failing example that I have. Please debug it. Yeah? Controls are very important. Sometimes it takes a lot of input trials to find a falsifying example. And here the default is 100. You can change the default. Here all it's saying is that do 1,000 different inputs, please, and just leave out everything that runs for more than 5 seconds, and don't shrink. So you have the option not to shrink as well, because sometimes shrinking can be quite computationally intensive. Then you have a lot of controls on how you want to generate your strategies. Like I want floats, but I don't want infinities. I don't want nands. Here I might be doing something with a standard deviation. I don't want a 0 standard deviation, maybe. But there's a lot of controls. Even more controls, filters, event is a bit like logging, and sometimes you want to check whether or not the data is good on the fly, then you have assume. All the stuff is there. And what I found remarkable with Hypothesis is that sometimes I wonder, like, is it there? Like, is the feature there? And whatever it is that I want, it's there. Like, it's a very mature library. Yes? A what? Assume is that So it's a bit like filter. So here's integers, right? It's saying, okay, I want to get just the even integers. So that all the odd, so you're generating some random integers. If you get an odd integer, you just throw it out. You just don't try it for the test. Assume is very similar to filter, but then it's done during there. Maybe you have some intermediate results, and you know some intermediate results don't match your specification. You just throw it away. So here, it's another way of saying, it's a bit pointless here, because I could have said it in the strategies itself, but just throw everything that's now. Yeah, I hope that's clear. But there are strategies for everything. You don't have to write your own strategies. If you have custom classes, and it's composed of like this Python building blocks, right? You have that. You can generate your own custom classes strategies. And there, I work a lot with NumPy and Pandas. You can generate random NumPy arrays and Pandas data frame. This is really nice. You don't have to write your own strategies. Nice debugging tools. So for logging, you can go inside the strategies and then look at what kind of data it's been generating. And there are health checks. Sometimes you run property-based testing, you don't have that much control over what's actually running, and you want to look under the hood whether or not it's actually finishing. Sometimes some things don't finish, and you want to check that. And we'll go a little bit deeper into stateful testing, which is how do you then go about testing a stateful system. Check out Hypothesis. I really recommend it if you want to try your own property-based tests, and I hope today you'll be inspired to try property-based tests. And David McKeever has this has his own website. He writes a lot of blog posts. There's a lot on formal reasoning. I find it very interesting. There's some stuff on Brexit as well. He's Northern Irish, I think. Yeah, you can check that out as well. Okay, so the third thing I want to go through is common patterns in property-based testing. So I took quite a lot of these examples from Scott Vloschen's blog. He writes a blog called F# for Fun and Profit. I will link it in the slides. But great blog, really recommend it. Really funny guy as well. He has a lot of really nice YouTube videos. So common patterns, right? So these are basically patterns that that people usually use whenever they're writing their properties. So one thing is commutativity, different paths in destinations, and one example of that is this. If you have a list of numbers, you negate it and then sort, it should give you the same thing as if you sort it first, reverse the thing, and then you negate everything. And so this is an example of a commutativity property-based test. That this is ubiquitous, right? Like maybe you have some operations that happen always one after another, and actually there's some different ways that you can get there, and then you can just assert the result. There are also invariants. Some things never change. So for instance, if you sort something, the length shouldn't be different. Yeah? Or maybe you have some event-driven processing. It shouldn't change the chronological order of the time. So this is quite straightforward. Then there's idempotence. So this is an operation that it doesn't matter how many times you do it, the result should be the same. And this is quite obvious. If you sort something twice, you should get the same thing. Like it shouldn't have an effect. So there's a lot of operations that look like this. So these are common patterns. Also hard to prove, easy to verify. And again, I have this really nice example. Is like it's very easy to verify if whether or not a list is sorted. Like sorting the list might be something else. People design like really complicated algorithms to store, but verifying whether or not it's sorted is easy. So this is just checking whether or not the adjacent pairs, the second one is not smaller than the right one. This is This is straightforward. Inverse, a lot of the times you'll have encoder, decoder if you have a parser. I've got an example that's not as straightforward. So here is a strategy for a dictionary. You've got a session ID and an input, and presumably URL and code and parse QSL are inverses. But if you run this, you'll find a failure. It turns out that you can't have an empty string. Fine, you put an empty string. Actually, that's not good enough still, because you need to wrap it in a dictionary. And now this thing passes. So this is an example of an encode-decode pattern. Then there's a test oracle. This is very nice for migrations. Say you have two systems, two running systems, you want to make sure that they always give the same answer, then you just check for all valid inputs. And personally, my favorite one is called Just Do It, right? And you'll be very surprised that if you throw your functions a lot of valid input data, that maybe some errors occur. Just call the function, right? This one has an interesting mathematical representation. Check out Scott's work. He has a lot of these patterns and some other things as well for functional programming. He has a blog post called F# for Fun and Profit. F# is actually a very nice language as well. I really encourage you to check it out if you are into functional programming. Okay? So I'm going to move on to bigger examples and successful case studies. Hopefully to encourage you to try it out yourself. So I work a lot in machine learning systems. I do machine learning models, and we deploy it for the clients. And there's a lot of stuff that comes up very routinely. For example, in terms of processing data, you might have a pipeline of data processing steps. Can you make sure that you can handle the nonce, the nants, the ints properly? That it's not going to throw errors when some of these actually arrive. We do a lot of we do some price predictions, right? Like, so you're trying to predict the future of prices. And what happens here is that you don't want to be using forward-looking features, right? You have this nice supervised learning problem, and then your machine learning engineers go on a feature bonanza, and they make a lot of features. How do you make sure that your features are not forward-looking? Well, one thing to guarantee that is that if you truncate the future, your prediction should always stay the same, so that your information set does not contain the future. So that's also a very common property-based test. Then there's also some things on training an optimization algorithm. For example, if you're doing gradient descent, a step of gradient descent must always decrease the training loss, at least weekly. Then if you introduce L2 regularization, then the base loss must have increased, because now you're going from unpenalized to penalized. And then the L2 norm, the penalty must decrease. So you can prove this mathematically. And you can check this as well more formally with a property-based test. Then there's the deploying model. Sometimes you do a research model first before actually wrapping it up into a production model, and you want to make sure that it always gives the same answer, so you're using the oracle pattern. And sometimes predictions has to obey certain constraints or properties. Say it cannot be so different from your prediction last time, for instance, then you can check that as well. So these are real use cases for property-based tests in a machine learning pipeline. Then there's this general notion of testing stateful systems, where the whole idea is that you've got this system that contains state in it, and then you've got a series of valid actions. And the idea here is that you want to model post conditions. After you do a certain action, something must be true about the system. So, for instance, maybe you're, I don't know, you're writing a queue or something. If you put something to the queue, the number of items should be increased by 1. So that's a post condition, right? If you put something there, it should be there. That's a post condition. And it's not. I'm not going to go into the details of stateful testing, but I do want to cover one case study by Erlang DATS. So DATS is a database in Erlang, and one of their maintainers said that we know that there's a lurking bug somewhere in the DATS code. We have got bad object and premature end of line, actually EOF, whatever, every other month the last year. So people have been reporting to them, look, this is, there's something wrong. Like, I get these errors, but they cannot replicate it. People have the reports, it's very complex, they cannot replicate it. And they cannot track it down, so they cannot fix it. So, you remember John Hughes, one of the first guys who wrote the property-based testing library? He basically tried, he tried to do the just do it test, and then see if he gets an error. And it turns out that he can get the premature EOF error by doing this. He opens the file, he closes it. He opens the same file again, and then in parallel, you do a lookup and 2 inserts. This is the minimal failing example. If you don't open the file and close it, you don't get this error. If you don't do 2 inserts, you don't get this error. If you don't have a lookup, you don't get this error. So this is, for me, this is very convincing strength of property-based tests, because there's no one in this world who would sit down and create this unit test. No one's going to write this the first time around. And no one will be able to track down the bug and come up with this set of unit tests. So once you find this, you put it in your unit test suite and always test it. And for the record, you also find the bad object one as well. And to do that, you need to open the file, you insert something, and in parallel, you have to do a lookup. And then on that same thread, you do a delete, and at the same time, you do an open file. So again, no one's going to write this unit test. This is very complex. You get a bad object, replicable every time. And yes. Oh, sorry, excuse me. Yeah. So this is part of stateful testing, where you basically you have to specify beforehand what is the what's your valid actions, and then you just string different valid actions. And what John Hughes did is that, okay, you can have sequential actions, you can have parallel actions, and you just generate a lot of things. And I think he said you needed like half an hour to come up with these examples, because you really are trying different things. And finally, I don't have something concrete here, but there is a tech consultancy called Ambiata. They're based in Australia, and they do really good talks. They attend a lot of functional programming events, and this is one of their slides. They said that they do a majority property-based tests, so they're on the other end, right? Like they don't really write unit tests, they write property-based tests only. And I found this to be quite interesting. That people doing serious work in the industry is doing this. And, you know, for me, just to recap, what has been said here is that the essence of property-based tests is that you generate tests instead of writing them. And there's already a very mature library in Python to do that. It's called Hypothesis. Do give it a go. And if you're finding it difficult to write your first properties, try patterns. There's always some easy patterns that you can pick up and then you can write your very first property-based test. And it has been shown to be very effective in the industry. So people are onto something here. And you know, there's a lot of, you know, I know that maybe a lot of your Python hobbyists, you don't really write Python for a living, but there are other, it's getting more and more ubiquitous. There are other implementations in languages. And you know, whenever I try to convince people to do property-based tests, this the common complaint I get is that, yeah, but you know, for the kind of stuff that I'm doing, it's not really applicable. Like I can't even think of a property on top of my head. I think that's a mistake. I think you can always do property-based testing. I think it's a bug, right? You've basically made it, you've made a very stateful system that's very hard to model. And if you try to sneak some property-based testing into it, I personally feel that it'll improve your code base. Personal opinion. That's it from me. I'll probably share the slides somewhere, but there are references if you want to check them out. There's papers and blog posts. Yeah, thank you so much. Thanks for listening.
Thank you very much, Anthony. So I'd like to ask the crowd if you have any questions about property-based testing or hypothesis. Yes, Albert.
Do you have a mic there? Yes, so my question is like, what's your approach for the pattern for like negative? Like, it feels like it was all like positive inputs. Mm-hmm. Like it would result into an okay. What's the, like, for example, the inverse? Like the function is supposed to not work if this was the input. For example, like if instead of passing, if my function is supposed to return an exception, if I pass it strings instead of integers, how do I test for the instance where I pass it strings?
So I think a lot of it would come in your strategies. So there will be some cases where you'd expect to throw an integer, an exception, then you would make another strategy for that. Specifically for valid inputs that throw exceptions. Then you do assert that there is an exception there. But then for the stuff that should return something, it shouldn't, let's say. But it's all in the strategies.
So you mentioned one more thing, like the bug, where if it doesn't apply to you, then it's a bug. So for example, in the test case, the lightning talk a while ago, there was one guy who was doing a test case of Roman numerals to numbers conversion. Like how would you property-based test that?
So I would imagine the Roman numerals, it's one of those things that it takes some time for you to come up with how to make a Roman numeral. But once you have a Roman numeral, it's easy for you to know what number that is.
So it feels like in order to generate the Roman numeral, that's exactly what your function is.
But then there exists an easy inverse, right? I can convert Roman numeral back to the number, to a decimal number. I just check, you just do an inverse pattern.
Okay.
So yeah, that's one way to do it. I'm sure there are other patterns you can do.
We have one question at the back, and then I'll go back to you.
Hi. So I have a question. So I know that this code by David is basically saying you can use property-based testing for everything.
Yeah.
But surely not, right? So like, what are the cases where you would recommend that you stick to regular testing rather than property-based?
Oh, okay. So just to be clear, property-based tests is not something that you would do in place of unit tests. Always write your unit test. Okay. A lot of people, when they're doing their TDD cycle, they'll do unit tests first. So you always have your unit test. But then what I personally do is that I'll have unit tests as inside my TDD cycle, and then I'll step back and then see, okay, these are some of the properties to make it robust. And then I'll integrate some property-based tests into it. That's how I do it, but I know for a fact that John Hughes and some other people that are more hardcore, they do a property first test. So in their TDD cycle, they first write a property, then they actually code it up. I guess if you do this, then by definition, you'll get all your property-based tests. And also, sometimes you have a system it takes a long time to run, and the recommendation for this is that you do a unit test or do minimal, you don't try so many examples on your properties-based test on your local machine, but then on your CI/CD process, you try more examples. Then I'll report back to you on the errors. So I think that's one condition where it's really inconvenient to run property-based tests, because you can't run something 1,000 times.
Hello. Really interesting approach to testing. But for the hypothesis library specifically, is there a way for it to, for example, it finds an example, a failed example, and then because it's random, on the next run it can be not existent, right? So is there a way for it to pin that example, or you have to create a separate unit test that specifically uses those examples?
So that's one of the questions, right? Can it do X? The answer is yes for all X. So basically what it does is that it finds a failing example and it'll cache that example. And then so that the next time you try it, maybe you're inside a cycle, next time you try it, it'll make sure that it'll try that first. So you don't have to cache anything. So it's smart.
It stores a cache file that has those cache examples.
Yes.
And you recommend for it to be committed as well, right?
Oh no. I mean I don't like. I try not to commit a code that where you think it's there's a failing test. And
no, I mean the example, the cache one. Is it somewhere in the where is it stored?
There'll be a .cache, .hypothesis cache directory that I put in git ignore. I don't commit it.
You don't commit the example. So
but so if it's important, I'll add it as a unit test. But I guess it's different. Okay. Different style, right? I don't like huge repositories tracking histories of huge data.
So the recommendation is for it not to be part of the repo.
I would consult. I guess David's documentation is very expensive, but I personally don't do that.
Okay. Thanks.
Thank you.
Do we have other questions? Yes.
Hi, Ian. I have a question. I've been using a Python unit test, which is pre-built library on Python. I'm just wondering if does hypothesis also have like a code coverage? Does it like spit out like a report of how many modules have been?
I use code coverage as well, but I don't know if that works. So good question. I don't know the answer to that.
Okay.
Sorry.
Sure.
Do we have other questions? Yes.
Well, I'm not sure, but this question is related to property-based testing. How do we property-based test the max stubs and pick objects?
How do we property-based test what? Sorry?
Max stubs and pick objects.
Sorry, I don't understand. Max?
Pick objects.
Oh, mocks. Okay. So actually, you make mocks to sort of model a certain behavior, right? It's not the mocks itself that you're trying to test. And I guess this sort of goes back to this stateful testing where you want to create some sort of a model, not exactly mock, but it's like a model of your complex system, and you want to test like a specific behavior of it. then this is a more general version of mocks. I hope that makes sense. Check out the documentation. It's quite complex. I don't want to put a wall of code in the slides, but I don't. Yes, please.
Sorry, I came in late, but is probability-based testing something like formal verification?
No. It's not a theorem prover. So it's getting you closer to that. In that you're writing, you're trying to define a space of all possible inputs.